today I'll be talking about the NetLogo program that we use for the agent simulation of blockchain technology. So here are the model settings. There's a 21 by 21 area that we use to represent the whole tax system. And in this environment, there are resources, objects, and obstacles for the three agents, which are auditors, traditional taxpayers, and blockchain taxpayers to live and interact with. There are rules that set incentives to move and whether to allow the agents and individuals to change their initial feature set, such as changing from traditional taxpayers to blockchain taxpayers, based on the consequences of themselves and their neighbors' previous actions. So each agent's behavior is influenced by the incentive of their own economic interests, called cost and benefit, and under initial conditions, auditors are first equipped with blockchain and then invite about 4% of traditional taxpayers voluntarily or mandatorily to join. Then the IRS sets rules that rewards the rest for using blockchain, increases the auditing coverage, and raises punishment for tax filings. We assume that taxpayers seek to minimize tax compliance costs in their actions and decisions, and when economic incentive plus regulation affects taxpayers' behavior, more and more taxpayers will convert to blockchain. So, how does the algorithm work? Each agent's behavior is not only influenced by the incentive of themselves, but also influenced by other agents in the system, called a neighborhood effect. Agents pair up with all immediate neighbors and then produce a bounty if they are cooperative, which increases the resources of their neighbors and themselves. For example, the code up here redistributes rations for each agent for each period using for loops. This means that if you cooperate, you and your 8 surrounding neighbors will put bounty in the pot and then share it. If you don't cooperate, then you get to keep your bounty. So here's the setup with a graph and a table. There are different colors and agents that are represented in the model. And in period 1, which is the initial setup, there are about 20 blockchain taxpayers, which is about 4%, 389 traditional taxpayers, and 32 auditors. From the simulation, we can see an increasing number of blockchain taxpayers and a decreasing number of traditional taxpayers with each iteration of our simulation. This graph shows the first 6 periods of our simulation, where it is evident that the number of traditional taxpayers, which is represented by the red line, is decreasing. The number of blockchain taxpayers, which is represented by the green line, is increasing, and the number of auditors, which is represented by the blue line, is also increasing, which indicates more spending of government resources. Eventually, traditional taxpayers are replaced by blockchain taxpayers. So this graph shows 13 periods of the simulation, which has the traditional taxpayers reaching 0. So there are several control variables in our simulation, such as the change in IRS's efficiency, the change in punishment cost for not cooperating, probability of changing from traditional taxpayers to blockchain taxpayers, and the bounty or reward of changing to blockchain taxpayers. However, simulation results are very sensitive to the first 2 factors, which are efficiency and punishment. The simulation shows that when the IRS increases its efficiency, it takes less time for the number of blockchain taxpayers with cooperative behavior to reach the same high level, and for the number of traditional taxpayers with non-cooperative behavior to reach the same low level as before in the graph. The graph shows this increased efficiency, and the numbers vary for each simulation. However, with a default cost of 1 and a punishment of 100, it takes 12 periods for the traditional taxpayers to reach 0, 20 periods for auditors to reach 0, and for 20 for the number of periods for the auditors to reach 0, and with an efficiency cost of 0.8, however, the number of periods is down to 10 and 19 instead of 12 and 20 for traditional and auditors to reach 0. The graph shows the auditing increasing then decreasing, which indicates that the resources have been used efficiently. The simulation also shows that if the IRS increases its punishment, it will accelerate the process by mitigating the number of traditional taxpayers with non-cooperative behavior and increasing the number of blockchain taxpayers with cooperative behavior in the system. This is shown in the graph above. And with a punishment of 150 instead of 100, the number of periods is down to 10 for traditional and 15 for auditors instead of 12 and 20. This will save some government auditing resources, shown by the blue line, and shorten the process to replace the old system. And that's how this NetLogo models the blockchain technology in the tax system.